Okay, back for the rest of the calculated portion. So it says, here's a function k cubed plus x here, and 16 over k squared minus x here, and it says functions defined above where k is a constant, for what value of k, if any, is f continuous. So f is going to be continuous if when I plug a 3 into here and a 3 into here, I get out the same y value. So I'm going to go ahead and do that. So I get k cubed plus 3 equals 16 over k squared minus 3. So I'm going to multiply both sides by k squared minus 3. So I have k cubed plus 3 times k squared minus 3 equals 16. If I multiply these, I get k to the 5th minus 3k cubed plus 3k squared minus 9 equals 16. So I get k to the 5th minus 3k cubed plus 3k squared minus 25 equals 0. So I'm going to go ahead and solve this. So I'm going to treat k like a variable. So I'm going to go to y equals, and I'm going to plug in x to the 5th minus 3x to the 3rd plus 3x squared minus 25. And I'm going to graph that. I'm going to do it looks like this. And I'm interested when that crosses the x-axis, and that looks to clearly be the 2.081 value. Next one says, we have this function here, which of the following things must be true? So all we know here is when it is continuous, and whenever I see the word continuous on a calculus test, I think it must not be differentiable, because if it was, they would have told me that. So I have a point here, here, and here, and they asked me which of these must be true. So f can have at most 1, 0. I don't see why it couldn't have crossed multiple times, so I'm going to say no there. F has a relative max at 2, maybe, but maybe it went up here and then came back down. So get rid of that one. It says there exists at least one place where f of c equals 4. Well, if I'm continuous, I'm going to go from negative 9 to 5. I definitely got to cross 4, so c is true. D would be true. The average slope has to equal the instantaneous slope if we were differentiable, but we're not. Next one says, if f is the antiderivative of g, so that means that this g function is equal to f prime. It says, which following is the x coordinate of the location of a local max for f of x? So this is the derivative, so I'm going to go to y equals, and I'm going to go ahead and put that derivative in. So I've got 3 minus the square root of x squared plus x plus, can't hit plus apparently, for cosine x. I'm going to make sure I'm in radians. I'm working on geometry too. And I'm going to go ahead and graph this. The local max will be the place where this goes from positive to negative. So I could calculate that 0 right there, or I could look and see that the only thing it could be is 3.140. Next one says, here's a graph of f of x, which of the following could be the graph of f prime. So I'm graphing the values of the slope. This is a steady positive slope. So I'm looking, that one looks good, that one does not. That one looks good, that one looks good. Then this corner point, I'm going to have no slope. So they don't show any slope there, but this slope goes from positive immediately to negative. So I would need to have a negative value, going just to the right of 2, and that eliminates this guy. And this guy, if I look here, this seems to make sense because that looks like a parabola, and the derivative of a parabola is a line. Let's go with A. It says, at the time here, particle is moving at this velocity, let t equal be the time at which the particle changes direction from left to right. So left to right means from negative to positive. What is the total distance traveled by the particle during that time? So first thing I got to do is find b. So I'm going to go to y equals. I'm going to plug in this function. So I've got x sine of x to the 3rd. I'll go ahead and graph that. I'm looking for the place. Ooh, see, this is a bad looking graph here. So they told me it was only from 0 to 2, so I'm going to go ahead and change my window. I'm going to go window 0 to 2, and then I'm going to hit zoom 0. That's again the zoom fit button that will just show me the picture I want to see once I pick the X's. All right, so I'm looking the place where we go from negative to positive, so I'm looking for that place right there. So I'm going to hit second, calculate 0, and then I'm going to bound it. So I'm going to go right over here. I'm going to hit enter, and then I'm going to move over here. I'm going to hit enter. I'm going to hit enter again. So B equals that 1.845 value. So B equals 1.845. And then it says, what is the total distance traveled? So distance traveled, you'll recall, is the integral from 0 to 1.845. Distance is the absolute value of my function. So I'm going to go back to y equals, and I'm going to go to math, number, absolute value, and I'm going to put this function back in. There may be a better way to do that. If you know it, use it. I'm going to graph that. I love that pogo stick looking thing. I'm going to hit second, calculate 7. I'm going to go from 0 to 1.845. I wouldn't use that adjusted one on the free response, but we're okay here. Wait for it to calculate, and I get 1.011. And I actually got 1.012 kind of, but it's the only one that's close, so we'll go there. 88 says, let this be a function. It says, for how many values x in the open interval here does the instantaneous rate of change of f equal the average rate of change on the closed interval? Actually, I'm going to pick this one up here. I'm going to do the last three on a different video.